Had no interaction with you whatsoever on these related rate questions. I have no idea how you're doing with these, but I am going to go over my little system here on how to do this. So this is a tried and true system. Okay, this works. As far as we know, this is the best way this could possibly work. Have you ever had a teacher that gave you a word question, like I mentioned in the video one time, and they just said, just read it and figure it out? And figured out pretty quick that most of the time doesn't work. Most of the time, you can't just read it and figure it out. That's the challenge. So I wanted to review with you guys kind of this little process. Whenever you run into a word problem like this, and really honestly, this is some of the very first word problems you've seen in this class, what's the very first thing you should do? You should put a box around what are we supposed to find? That's right. So as you read this, ignore some of the details like who cares that the man is 6 feet tall? Who cares that there's a light perhaps? Let's try to figure out what is the thing we're supposed to actually find. Hunter. There we go. It's right here. I'm going to put a box around that. And oftentimes, I guess I need to unfreeze. Oftentimes the objective is going to be in the form of a question. Like, can you find this? Sometimes it'll be in the form of more of like a command, like find the value of or whatever. And why did it go away? I don't know. So what I'm going to do here is write dl dt. That is my unknown. So I just put that as a question mark. Once you have discovered what it is that we are supposed to find, these are called related rates questions. And so that means there's at least two rates, maybe more. There's at least two rates that are related somehow. That's why it's called related rates. So we want to go and we want to underline any of the rates that we can find. Do you see anything? Say again?
5 feet per second.
What told you that was actually a rate?
Per second.
Feet per second? Yeah, for sure, that's a rate. What's another indicator that that's a rate? Doesn't it say rate? Yeah, the units, like Carter mentioned, totally agree. It even says the word rate. It won't always, but it often will. I'm going to underline that. So this guy is walking at a rate of 5 feet per second away from a light. And this is where this gets a little bit weird as far as what kind of a variable am I going to use here. And oftentimes when I look at this, I'm like, oh gosh, dLdt, L for length of shadow. I'm getting kind of confused on how I should label this unit, or this variable here. Do you guys feel like this is one where a picture is good? Yeah? Okay, so I'm going to sketch a picture. It's going to be super basic. Hopefully yours is just as good and just as basic. There is my lamp post. I'll even make the top yellow. Here's the ground. Here's the guy. He's going to wear blue jeans and a black shirt. And then wouldn't the shadow be created by that part of the beam of light going kind of right at the top of his head? So I need to extend the ground here just a little bit, like so. And now I'm feeling a little bit better now that I've got this picture. I can kind of see what's going on. We need to label some stuff. Some of the stuff is pretty obvious and constant. The light is 15 feet above the ground, so I could label that side, that little part of the picture 15. What else could I label similarly?
He's 10 feet away from us.
We got to be really careful with that. Let's not do that.
That man's 6 feet tall.
Isn't he always 6 feet tall? And isn't the lamp always 15 feet tall? I want to go back to what Hunter said. He wanted to label this with a 10. Is that distance from the lamppost to the guy, is that always 10? It's not. And so I am not going to label anything in my picture like that that's not always 10. Now he is always 6 feet tall. And the lamppost is always 15 feet tall. He's probably not growing in this scenario. At least we're not going to take that into account if he is. So I can't label that little part with a 10. He's moving. He's walking away from the lamppost. So any suggestions on, instead of a 10, how could I label that distance? X, B for base, X for horizontal distance. I think in this case, I probably personally would probably go with X because this isn't really the base of the triangle. Like it's part of the base, right? But it's not the whole base. If you label it with a B, I mean, that doesn't really matter. We just want to be consistent with how you labeled it. Then also we got this whole length of the shadow thing. Where would the shadow actually start?
At the end of X.
At the guy, right? Yeah. At the guy's feet. Where would it end?
The light B minus X.
I'm not looking for an expression. I'm just looking for more of just a general concept. Starts at his feet, ends where? Yeah, out there at the end of the orange part of the triangle. So I'll try to represent that. Here is his shadow right there. And based on how we set up that variable, I'm going to say that from his feet out to the end, I'm going to call that L, because that's what we set up to be our variable for the length of the shadow, dl/dt. L, okay. So I think this picture is going to help immensely, and we won't always draw a picture, but often we will. Okay, so dl/dt is our unknown. I just underlined that sentence in red, or that phrase in red. Now that we have this labeled, can anybody tell me how we should represent the rate that he's walking away from the light? Like, what would those variables look like? I feel really good about Hunter. He's had a lot of really good answers. Can somebody else jump in? What do you think, Carter? No? I thought you were raising your hand. Nate, what do you think?
dx dt.
Why would you say dx dt? Yeah, isn't the lamppost the only thing that's stationary in this? He's walking away from the lamppost at a certain rate. So dx dt would be his rate of walking, right? His rate of position change. And I know what this is. It's 5. 5 feet per second, technically. Okay, so in the terminology that I used in the videos, that 10 feet is quite important. It's going to be really important at the very end. What did I call that 10 feet in my video? Freeze frame moment. That's right. So what's the key word to help us understand that that's the freeze frame moment?
When.
Yeah, when. When you see the word when, the thing that comes next is often going to be your freeze frame moment. So when he is 10 feet from the base, so that would be when L is 5 or when X is 5. It's when X is 5. Yep. So freeze frame moment, or not 5, 10. When X is 10. Sorry about that. Okay. So this is where at times there's going to be some challenges as far as how do I do this. Sometimes it's going to be easy, like the video from the other day. The relationship was given to you. Here the relationship is not given to you. So I want you to think. You've got an L, you've got an X, you've got some not so subtle triangles. Can you think of what might relate all this stuff together? A ratio. Who said ratio? A ratio, Cole says. What ratio, sorry, who was it? It was Carson. Sorry, Carson. Carson, what would you propose as far as a ratio?
15 and X and 6 and L.
So give me, I'm not going to write the word and in my relationship. Tell me exactly what we should write.
15 over X equals 6 over L.
15 over X equals 6 over L. Say again? 15 over X plus L? Why? What's wrong with just X?
Oh, yeah. Well, it's not the whole triangle.
It's not part of it. Yeah, it's not a whole side of a triangle, is it? So you guys proposed 15 over X plus L. Carson, you kind of nodded in agreement at some point in there.
Yeah.
You feeling okay about that? I got to say, I'm impressed. I've done this question many times over the years, and it's rare that anybody in the class comes up with a nice relationship pretty quickly. Did you guys pick up on the idea that the big triangle and the little triangle are similar? And so Carson's idea of ratios and proportions is actually right on the money here. It's pretty good. Okay, so again, to kind of use the terminology I use in my video, do you all see how I've picked out my movie? Yes? No?
Yes.
There's my movie. It's the 15 over x plus L equals 6 over L movie. I want to tell you, though, before I push play on this thing, I want to do a little rearranging of the couch cushions to get a little more comfortable so I can watch this movie. So can anybody think of how could I do some rearranging with this thing to make it a little more comfortable? Cross multiply, yes. So that would be 15L equals 6x plus 6L. Can anybody see any further rearranging of the couch cushions to make this even more comfortable? Hey, there we go. 9L equals 6x. We could maybe do a little bit more, but this is looking a lot more comfortable than that thing with the fractions for sure. And I'm feeling like maybe I'm ready to push play on my movie. Does that make sense? So really the movie I want to watch is the 9L equals 6x movie. How do I push play in calculus? ddt, right? Derivative with respect to time. I hope that the analogy holds for you still, right? Because when you push the little triangle on YouTube or the triangle on the Blu-ray or whatever you're watching, doesn't time start? Time starts to move up. So ddt, pushing play, get it? It's a pretty good analogy, yeah? Okay, good. So can we actually do the ddt of these? We'll find out. Notice that there are no t's whatsoever in my relationship. They're L's and X's. So you see how the chain rule factor is going to feature a prominent role in this movie? Luke, what do you think? You could, and so that was you could rearrange the couch cushions a little bit more. You could divide both sides by 6 or 9. And I would say 9 would probably make the most sense because in the end we want dLdt. I'm just going to do it this way just because. What do you guys think? What's ddt of 9L?
9 DLD.
That's correct. It's a chain rule factor of dLdt, and the rate of change of 9L is just 9. So once again, I'm feeling really positive about Hunter and his grasp of this because he's answering a lot of these questions I'm throwing at you quite well. Anybody do the ddt of 6x?
6 dx dt.
Fantastic. Also, perfect. Got a chain rule factor of dx dt, and the rate of change of 6x is just 6. Okay, so now we have our movie playing. We want to put in all the stuff that we do know. I know that dx dt is 5, so I'm going to come over here and say 9 dl dt equals 6 times 5. And dl dt, if I divide by 9, ends up being 30 over 9. So dl dt would be 10 over 3. What kind of units would go on this rate of change of length of shadow?
Per second.
It would be feet per second. So if you paid really close attention to the videos that I sent out for the other examples, and if you're really closely paying attention to this one is a little bit different than all the other ones because there's something that I didn't have to use. I never had to use the freeze frame moment. There was no moment when I had to use the freeze frame moment because when you've got similar triangles, as long as the guy just keeps walking at the same rate, isn't the proportional relationship between all the lengths of the sides just going to stay the same? No matter where he is, whether he's 10 feet from the base of the light or 20 feet from the base of the light or 100 feet from the base of the light, that proportional relationship will remain the same. So the only situation where that freeze frame moment doesn't really matter is when you've got similar triangles, like the proverbial man walking away from the lamp or towards the lamp or something. So here we didn't have to use the freeze frame moment. Pretty much all the other situations, we definitely will. All right. How are we doing? We got some thumbs up. I got a good couple of thumbs up. All right, well then let's see how far we can get with number 2. A lot of this is in the setup. Why don't you guys take a second and read number 2 and a ladder 25 feet long. We've done one like this before, but this one's different. I think I had one of these in one of the videos, if I remember correctly. You get the 25-foot long ladder. Once again, somebody is pulling the base of the ladder away from the wall. This time, it asks for something a little bit different. So, has anybody identified yet what it is we're supposed to find?
The rate of,
We're not supposed to find theta.
the rate
No.
of theta is changing every time.
That would be it, yes. So what is the rate of change of the angle between the ladder and the ground? And Hunter has quickly identified what that could look like symbolically. What did you say? Say it out loud. Okay. What do you think, Luke?
D theta over dt.
Don't we use theta a lot for angles? I think that does make sense. So I would say d theta dt is my unknown. And kind of like when we did the ladder question before, I think to me this begs a picture, doesn't it? So I've got a wall, and I've got the ground, and I always make my ladder red for some reason. What's the one thing, I guess there's two things. What's the main one thing that's constant in this situation? Yeah, length of ladder is 25. So that is not changing, but almost everything else is. The house probably still have a 90-degree angle with the ground, but almost everything else is changing. Did it make sense how I labeled it before? I think I had an X here and a Y there. Y'all okay with that? Okay. Where would my theta go? What part of the triangle? Say again? Oh, between the X and the 25? Yeah. Kind of that lower right, because it describes it as the angle between the ladder and the ground. I think that should be our theta. Do you guys see any other rates going on here? I got my objective boxed. Carter, what do you see?
Per second, that the ladder goes away from.
Yeah, that's right. Yeah, base is pulled away at a rate, and once again the word rate is in there, 2 feet per second. So could anybody identify what kind of a Leibniz derivative variable this would look like? Say again? So I use the letter x for my base. So would you be okay with dx dt?
Yeah.
Okay. So dx dt,
Equals 2.
and that is 2. Agreed. Anybody identify the freeze frame moment? Yeah, when, that's your key word, the base is 15. So my freeze frame would be when what is 15? X is 15. There we go. We don't want to just put freeze frame is 15. We want to say when X is 15. We're going to get to a pretty good place here. Can anybody think of a relating equation that would relate all this stuff? We got theta, we got X, we got Y, we got 25. What might relate this stuff together? Luke, what do you think?
Cosine theta is equal to x over 25.
Cosine of theta equals adjacent over hypotenuse. You agree with me that that is a fantastic relationship? It's got an angle, so doesn't it have to have a trig, something or other in there somewhere? Let's keep going. I got it 1 minute. We'll get as far as we can. We need to rearrange the couch cushions a little bit. We could clean this up just a little. What do you think we could do? You could multiply both sides by 25. That's debatable whether that's good or not. And I could go either way. Joe's kind of giving me the stink eye, like, do we have to do that? And I would say, no, that's okay. I'm not offended. I don't think we have to do that, but it's one way you could do it. You know what? I'll just leave it alone. I need to do ddt of this.
Could we do an inverse function to get theta by itself?
You could, but then you'd have to do the derivative of an inverse, which you do know how to do, so that could work fine.
Right.
I tend to stay away from that, and I don't know why, but it could work fine.
Okay.
Yep. Okay, real quick, we'll finish with this. What's ddt of cosine theta? Negative sine theta times d theta dt. And then what's ddt of x over 25? This is why I kind of wanted to multiply the 25 over. It's a little bit awkward. There we go. It's 1/25 times dx dt. So I'll explain why real quick. Isn't x over 25 maybe better written as 1/25 times x?
Because then you don't think that it's a fraction.
Yeah, now it's really not because it's a constant multiple rule. You just ignore the 1/25, you do the ddt of x, and multiply back in. Can you all see how at this point we just have to do the sine of theta, plug in the dx dt, and we're essentially done? Yes, no?
Should we be able to
It's-
do that without a calculator?
You can. If you want to stick around, I'll show you how. But otherwise, you guys are good to go. Have a wonderful rest of your day and weekend. Hi. So, Zach, what I would do here, so my freeze frame moment is when the base is 15. So at the freeze frame moment, I'm going to draw my triangle at the freeze frame moment. So 25 and 15. If you do the Pythagorean theorem, this is a 20. So this is my theta. So I would just do sine of theta is opposite over hypotenuse. So this would be negative 20 25ths times d theta dt equals 1/25 times 2. Just multiply by reciprocal and you're done. Does that make sense?
Yeah.
Okay.
These are big people compared to the ones I have.
Oh, they are. They're so big and mature.
They are.
They are. They really are. It's true. I'm writing the answer up here if you're curious. Anybody know what the units would be here? Big bonus points. Do you know the units? Whoa, Carson is with it. Nice work. Radians per second. Yeah. Thank you. Have a great day, you guys.